Alright, tonight's notes are the last notes of the semester. We're going to be looking at the greenhouse effect, which is a function of the atmosphere that helps to keep our Earth warm. So we're going to see where that energy comes from, what happens to it in the atmosphere, and how it functions to keep our Earth a nice, habitable place. So just as a little review from last night's stuff and the stuff we looked at in class yesterday, with solar energy, right, electromagnetic waves leave the sun, they reach Earth. Some are absorbed by the atmosphere, right? We saw like the gamma rays and the UV rays absorbed by the atmosphere. Some get reflected straight back into space, in and out, and then some get absorbed by the Earth's surface itself. Right? If you've ever been outside on a sunny day, you know that the ground, especially dark surfaces, get really hot, right? That's absorbing heat, or absorbing energy rather. And then these absorbed electromagnetic waves become heat on the Earth. So, the Earth gives off this absorbed energy as infrared electromagnetic waves. So instead of like the sun gives off its energy as visible light, the Earth gives off its energy as infrared rays, or gives it off as heat. Right? And on a hot day you can kind of see this. You can't see the infrared waves, but the hot air causes the visible light to shimmer and wiggle as it moves through it. It causes it to get distorted. Excuse me. So the Earth gives off that absorbed energy from the sun as infrared electromagnetic waves. Now, as these infrared waves head towards outer space, some of them get trapped. Right? Carbon dioxide, water vapor, and other gases that we call greenhouse gases trap some of this infrared energy from Earth. So don't worry about the numbers here. This just kind of illustrates it. Right, this energy is coming from the Earth upwards, and a lot of it gets trapped and radiated right back down to Earth. It kind of stays here and stays warm. Right? This trapping of the Earth's heat by these greenhouse gases warms up our atmosphere, and we call that the greenhouse effect. And this is a good thing, right? Without the greenhouse effect, the Earth would be a frozen ball of rock and ice. Right? Temperatures would be well below negative 200 degrees, right? And so the Earth would be really cold. Now normally, energy coming in from the sun is balanced by heat radiating off from Earth. So these two balance each other, and the Earth's overall temperature stays pretty similar. Right? The greenhouse effect keeps it nice and warm, but extra heat gets radiated into space so it doesn't get too hot. However, as we'll see next semester, human activities have changed the amounts of those greenhouse gases in the atmosphere, especially carbon dioxide, which has changed our greenhouse effect. And we call that global warming or climate change. And we'll look at that more next semester. But the greenhouse effect on its own is very good. We get this, a nice warm blue planet, as opposed to this, a snowbally, frozen, cold planet. All right, and that's it. That's all there is for the greenhouse effect. Nice short video tonight. 3 questions, and you're done with notes for this semester. I'll see you guys in class tomorrow.